So, good afternoon, everyone. My name is Mike. I will be taking care of you today. If you have any questions, feel free to put them in the questions box. Now, today we're focusing on laser, plasma, and Waterjet, which all three of them really use the same tool path. So, whether you're using a laser or a Waterjet, I primarily do plasma stuff. That's what the most I work with is usually with plasma. So, I want to start off with something very, very simple. And I do this just so you guys can hopefully get an idea of if there's anything going wrong at the machine. So what I'm going to start out with, like I said, very simple. I'm going to make a 4x4 square. All right. Now you can put radiuses on the corner if you want, but I want something that's very easy to measure. All right. And so whether you move it into the upper right-hand quadrant or you leave it right at XYZ 0 is really dependent on how your machine or how you machine. For me, a lot of times I'll draw it on center, and depending on my machine, you know, with some of your guys' plasmas, you'll have work offsets, G41 or G41, like a G54, G55. You can actually set up those work offsets. But for a lot of you others, you don't actually have a work offset at all. You use a G92. So for anyone, I believe it's the Bailey plasmas. They use a G92. And so basically that just means wherever the head is sitting, when I hit go, that becomes my start location. So I'm going to start from there. So if I leave this here at XYZ 0, I'm going to use the center as the origin. So if I was actually setting this up on my plasma, I would have a piece of material that's larger than 4x4 by however much you want to go. I'd have it on the machine. I'd go find the middle of it, and I'd set the head right there, and I'd say, let's start cutting now. And that's going to use that G92. You could also set up your work offset. If you use G54s or your machine uses G54s, you could also just set up a work offset for the middle of the part as well, which is essentially what we're defining when we define the origin. So the amount of work, the difference in amount of work that you're doing is really nothing. So instead of going from the corner of this part, I'm going to go from dead center. Now, the main thing I'm testing here when I cut this 4x4 square is the diameter that I have set the right diameter? You know, we default it to, an 1/8 inch or 100 thousandths or something, but you might have a different nozzle on your machine that makes it smaller, larger, what have you. And you really can't tell until you cut a part and you take measurements. So we start off with a 4x4 square. Now, if I go and cut this and it cuts at a 4x4 square, great. We got nothing to change. Nothing's going wrong. But if I go and cut this and the part comes out smaller than it's supposed to be, then what that means is that our tool is too large for the cut, or the tool is actually larger than what we have it defined as. So if we have it defined as 100 thousandths and it makes our part too small, we can now calculate how much larger the diameter was supposed to be defined as. And if it cuts the part too large, then if we had, again, our cutter set to 100 thousandths and it cuts the part too large, that means that the nozzle, the spray, is actually smaller than 100 thousandths. So this is a really easy check that anyone can do. You run a sample program. If you ever do an online training with me, if you're still new to the machine, this is a part that I would create with you and show you and explain to you. Go make a cut on this, go cut the part out and then measure it. And if it's 4 inches, we're spot on. If it's under, tool's too small. If it's over, switch that. If it's undersized, then tool's too large. If it's oversized, then stream's too small. So just going to go down here to the CAM tree, go to CAM defaults and start my new job. Before I do this, I'll just show you guys, for anyone that's new in here, there's a cheat sheet for starting a job and machining a job inside of BobCAD. That cheat sheet is found inside the help system. So you could go to File and you could go to the help system that way. Another quick way of getting there is the main X to shut down the software. Just below it, you have this little question mark right here. And you're just going to click on it. And we'll just wait until it launches. This should be, mine's pulling up the newest one from online. So we're just waiting for it to load. Give it 1 second. There it is. It popped up on my other screen. So anytime this help system loads, anytime it opens up, make it big, it always opens to the same page. It always opens to this introduction page. So if you can get to here, the next step is you go to using CAM, and then right here, read me first CAM quick guide. Now, for a lot of you, these options will only have to be done once. And this is kind of why I like to start with this simple 4x4 square, because I can go in and kind of define, or I can find out the size. And after I get the size set, you guys are literally able to save the toolpath and reuse it over and over and over again. It's one of the best parts about laser plasma Waterjet is after you do it a few times, it just gets easier and easier. So right here, we have our start a new CAM job. This is where we have to tell BobCAD that we're doing a milling job, but we're going to go pick, excuse me, either our laser, our plasma, or our Waterjet. So we're going to pick one of those three. And that's how we set the system into the right kind of mode. All right. Then we go in and we, number 2 here, we make our stock wizard and our machine setup. That's a step you can't skip. So you're going to do that regardless. And that's just where you're defining the size of the material you're cutting from, as well as the origin of the part or your work offset if that's what your machine uses. Now, step number 3 is it says select the stock material. It depends on how your machine runs. A lot of you guys, you're never even going to enter feed rates into BobCAD. All that stuff's going to be handled at the machine. Essentially, what BobCAD's going to give you is the path to follow, and then the machine's going to have the pierce settings and everything that it needs to actually cut the material based on if it's one of the Bailey plasmas that I have the most experience with, you literally have a flash drive that you load your cutting conditions from. So you'll have a flash drive, potentially you might have 10 flash drives. One's for 1/4 inch thick aluminum, one's for 1/4 inch thick steel. And so you'll have a flash drive for each different material. If you're using the Baileys, I'm not sure if you could put them all on one flash drive. When I was using it, I had like 4 different flash drives that had their settings. If you don't know where to get the settings or know the settings that you need to cut, the best thing to do is get the manual for the machine. If you guys are using if any of you have the Bailey plasmas and you're using that, the Thermal Dynamics A60, you can actually go online and find the PDF if you don't have it, but it's all over the place online. And in it, it tells you what you should be using for what your amperage should be. Everything you need is inside that manual for each different type of material. So you can go in your manual and find out what they recommend for feeds and speeds, torch heights, everything. All right. But the material itself for us doesn't really matter. BobCAD doesn't actually calculate feeds and speeds in laser, plasma, or Waterjet, regardless of what material you have. The only reason I would really ever spend the time to go in and set the correct material in BobCAD when I was doing this is so that if I generate a setup sheet or anything that would have a material listed, I would like it to have the right material listed. If I'm cutting aluminum and my default material is 1018 carbon steel, well, whenever I print a setup sheet or do anything, it's going to have 1018 carbon steel on it. So I definitely do spend the time to go in and set the material that I'm using. But if you didn't do that, it's not going to hurt. Some of you guys never change materials. Lucky you. So you get to use the same material. So really, at that point, it's kind of irrelevant of what you're doing. So step number 4 is where we start adding and creating our CAM features. Now, the best thing about this is after we test out this 4x4 cut, and we find out, hey, are all my settings right? Is my tool set correctly? I keep saying tool like it's a milling machine, but is my plasma diameter or my Waterjet or laser, is the diameter set correctly? And again, we're going to test that after we cut the part by measuring the part. If it's too large, your tool's too small. If it's too small, your tool's too large, or it's larger than what you have defined, or it's smaller than what you have defined. So that's what we're doing. But the thing is, step number 4 here has, you go make your tool path. Step number 5 is repeat step number 4 as many times as you need. And that's exactly what we're going to do. But we're going to do it a lot easier by using copy and paste and save and load. Most of the time, if I'm doing one part file, copy and paste is fine. And even a lot of you guys might notice a lot of your plasma jobs don't have multiple features. They have one feature, and it goes and cuts everything. So it really depends on what kind of job you're doing. But for us, we're going to be doing a lot of copying, a lot of pasting, or a lot of loading and saving. Every time we open a part, we're basically going to be able to use the same job or same tool path every single time. All right, so down below that, we then have step 6, check the machining order. If you're only using one tool path, you really don't have a machining order. You're going to have the order that it cuts in. So that one really doesn't apply here. Number 7, verify your tool assignment. We're not really calling out tool numbers, other than maybe one if your machine even needs it. So verifying your tool assignment is not really needed for laser, plasma, Waterjet. Number 8, we simulate the final program. Absolutely, we always want to do that. I always simulate. You'll catch a lot of mistakes that could potentially cause problems just by watching the simulation. We had I believe it happened to my boss just a few weeks ago. We were milling a small part, and the tool needed to lift up to go across the part to the other side. And he wasn't paying attention, and he didn't watch the simulation for the final time after he made a couple changes to depths and things. And he ended up lifting the tool. It needed to go up 300 thousandths to clear the part. He lifted it up 200 thousandths. And so when he moved over to the other side, he clipped the part, and he ended up breaking our little one of our little 1/8-inch end mills. So not the end of the world. Luckily, it was a cheap one, but simulating the program, had he simulated, he would have seen the tool go through the material and have a gouge in the part. But he was just in a rush, got out of a meeting, wanted to go run a part real quick, and ended up not paying attention to it and crashed the part. So always, always, always simulate that final result to find out if you have any problems. Step number 9 is we post the code. Absolutely, we're going to post the code. This is going to be dependent on your machine. We have post processors for a lot of the machines. We have posts for a lot of you guys' machines. If we don't have your post at this point, you could send us a sample code that runs on the machine, and we can actually go in and kind of copy the output of what you gave us so that you have a post that works. But at this point, I think most lasers, plasmas, and water jets, we have I won't say most. There's a lot of them that we do have a post for. And they're all so simple that usually we can get them working. And then finally, step 10, totally optional. You don't have to. Generating a setup sheet. If you're entering feeds and speeds into BobCAD, it could be beneficial to make a setup sheet because it can calculate the cycle times for you. But it all depends on how your machine goes. Again, some of you guys will put your feeds and speeds inside the BobCAD page. Some of you will not, and you'll just leave everything at 0. When you post the code, you look through the code, there won't be any feed rates output. There won't be any of that stuff. That stuff's going to be set at the machine. So again, this is just our little cheat sheet. I really like to show this off just for any of you real new users that need a little hand on just getting started. One of the things that I've met many people that struggle with is just that first step of how do I've drawn my part now. How do I get the cam to go? How do I start the cam? Well, step number 1 there, that blue link where it says new cam job, we can actually just click on new cam job and it's right there. So we have our cam tree all the way down. All right. So it'll tell you in the cam tree, we can right click on cam defaults, go to new job, or in the ribbon, we can click on new job, or in the quick access menu of the cam tree manager, we can click on new job. So there's 3 different ways to actually start a new job. It just depends on which option you decide to use. So the first way is if we right click on cam defaults, we have new job. The other one is this guy right up here, this little button on this quick access toolbar, add new job. And finally, the last one is on this cam tab here, new job. They all take you to the same exact place. So you're just going to go to the machining job. You'll pick your job type. And just so everyone knows, we're always going to be using milling. Milling is what we use. The way that we define that this is for a laser, a plasma, or a water jet is by going down here and picking the laser, the plasma, or the water jet. Now, some of you guys have lasers and everything in here already. They're kind of built into the system. all you guys with the Bailey routers, or sorry, the Bailey plasmas, we have 3 of them, the Fangling, the Rich Auto, and the Starfire. We have the Bailey Waterjet. I'm going to just be using the generic BC laser plasma or Waterjet. But yeah, look through here, and there might be one that already loaded with BobCAD. We have a lot of these machines and posts that actually show up with BobCAD. So take a look in there and see if you find what you're looking for. Like I said, I'm just going to go ahead and use the BC3X plasma. And then from here, we're on to step 2 on that page. So we're going to go right to the stock wizard. The first thing it asks us for is a workpiece. Now, a workpiece is a solid model that represents the final finished part. And I do not have a solid model. So we're not going to pick a workpiece. This is one of those things that if you don't have it, don't worry about it. Just skip it. So we'll just go ahead and hit next right here, or forward, or whatever it says. And I'm just going to change the stock size to just 6 by 6. Thickness wise, I'll just set this to something like an 1/8 inch. Whatever your size is. It's kind of it's relevant, but it's irrelevant depending on what you're setting up. I just want to go 1/8 of an inch because that seems realistic for a thickness of material I might use. So next, right here, we then have our origin. And I drew my part centered on XYZ0 specifically because that point there is my origin. And that's where I drew it. So I don't actually have to change anything here. I'm just going to scroll down to the bottom and hit OK. So again, if I go in and I right-click, let me first blank out the stock. So going in and actually adding the toolpath, I'm just going to right-click on Machine Setup 1. And the only toolpath you're going to use is a Mill 2 axis. From here, we select our geometry. So I'm just going to hold Shift and pick my part. And that's our chain select. Again, hold Shift, click on a chain of geometry. And if it's all good geometry, it's all connected properly, it will all light up at the same time. All right. For our chain here, I can actually go in and set the start point wherever I want. Now, one thing I want to point out, and this is something that it's really something that happens to a lot of milling people. So if your past or your other machines that you run are a milling machine or a router, then you do want to kind of pay attention here. So when you're doing a mill or you're doing a router job, you have a tool that's spinning, and that spinning motion can cause really deflection, and there's a lot of things, it can cause problems. Plasma doesn't have that issue. It doesn't really factor into that. So the direction of cut isn't as important. But what I found out from just doing BobCAD long enough is whenever I pick the geometry by default, the arrow that pops up, that arrow that we see on the left-hand side of that screen there, the arrow that pops up is always backwards. So he's kind of 180 off from what it should be. I want to usually, with mill and lathe, compensate to the left. And if you look at that arrow right now and you think about the direction it's moving in, and you think about the left side of it, that's going to put us on the inside of the part, which will end up 100%, making our part way too small. The other side is to the right. But because we don't have rotational forces, I can actually compensate to the right. And that's actually what I do. I usually set this up. The toolpath that I'm going to end up saving in just a few minutes here is going to have its compensation set to the right side of the part. All right. So I'm going to leave that there because to the right's going to put me on the outside. Now, I could go with the center of the part. I could go with this corner here and then potentially use something like a parallel lead. A lot of it's going to come down to, in real life, making cuts. What's next to your part? How long can you afford to make your lead? How long does it take to pierce? Those are the things you have to factor in. If I start here, though, I can use a nice parallel lead in, come off the part, cut around, and then exit with another parallel lead in right there. So that's what I'm going to go for. Total depth, it's a plasma, a laser, or a water jet. I'm going through the material pretty much regardless. Maybe laser, you could do a little bit of engraving. I've not done any of that myself, but whether I leave this as a 1/2 inch or I make it an 1/8 inch, doesn't really matter. What I usually recommend doing is set the depth of the tool path to the thickest material you'd ever cut. So if you're never going to go beyond a 1/2 inch, set your depth to a 1/2 of an inch. That way, when you do set up a job that has this 1/2 inch stock, when you go to simulate it, you will actually see the proper results of that job. So yeah, I'll leave it at a 1/2 inch. It helps me out because, again, I'm going to save this toolpath. And if I save this toolpath with a depth that's greater than any part that I plan on making, it works out perfect. So I'm just going to go ahead and hit OK. And then hit next. Right there's my square for the geometry, 1/2 inch depth. We'll go next again. Now for the strategy, on the toolpath that you're going to use, there's only one toolpath. It's going to be the the profile finish right here. So what we want to do is click on the profile rough and then hit the little red X there. Now you could use the profile rough over the profile finish. The benefit of using the profile finish over the profile rough is that it's set up as a finish pass. The rough pass is actually going to have, certain pages where material is being left on the part. Your allowance is being left on the part. And so this will, make it easy. Everything's zeroed out, so it's all ready for the finish. So we'll go next. Right here we have our tabs. You have kind of two ways of doing tabs. Yes, you can use tabs through here, and you could do tabs a bunch of different ways. My main way, I'll show you, the first one. So a number of tabs, you'd come in and just say, I want 4 tabs. And you'll see that did a pretty good job evenly spacing those tabs for me. That's where I would have put them anyway. But I could also do a length between tabs. And I had a guy in the class, in my seminar class just last week, who was playing with this, and he was setting his values to something like a 1/4 inch or maybe more. Let's go. I'll go 0.75. So that would be a 3/4 inch gap between each one of those dots. Lots of tabs. It'd be a ridiculous cut to do. Something like this, you wouldn't go with 3/4 of an inch. You'd go with 3 inches or 4 inches. You go 4 inches and you end up with 4 of them. Really, we got 16-inch perimeter anyway, so it's even. But that's just how it goes. So what I usually end up doing, and just because of the shape being so simple, it does get all 4 of these. But another way to actually handle your tabs is to use manual tabs. And then go in here and say edit tabs. But before you use manual tabs, always set the number of tabs to 1. If you set it to 4, and then you go and use manual tabs, I now have to go in and clear out 4 of them before I can go put my other ones on. So again, set it to 1. Actually, what happens if I set it to 0? So 0 doesn't work. So we'll set it to 1, and then use manual tabs and edit tabs. And what I do is I'm just going to come over here and I'm going to click on that point that's there. That's designating where that tab was going to be. And let's say I don't want all 4 of them. I just want 2 of them. So I can say I want one here and I want one here. And I'll just hit OK. And now we'll see those are the 2 tabs I have instead of all 4. Now right here we define the width of the tab. So I can go make this something, 1/8 inch right there. The angle for plasma, let's set it to 90. We don't really want to mess with that. And then the height of it really doesn't matter because instead of, normally what this option is going to do is on an end mill, it's going to lift the tool, cut across the part, but leave an area that's uncut. In the plasma laser Waterjet scenario, it's just going to shut off the plasma, feed across the area it didn't cut, turn back on, and continue cutting. So, again, I'm not going to use tabs on this right now. Right here we have our posting work offset number 1. So if your machine does use work offsets, G54, G55, or whatever your machine calls them, this is where you could set up the different work offsets. So we have work offset 1. That's going to be the equivalent of a G54. If you click that box there, you have a drop down. We have, looks like this one's got 54 work offsets built into it. So you could set up to 54 parts with their own individual work offset if you wanted to. I would not recommend that, but you could. For your output rotary angle, this is not something you'll use for plasma, so it's not something you need to worry about now. And then next. This contour ramping doesn't matter. All right, so the plasma tool. So this is really what we're testing. At this point, I have it set up as 1/8 of an inch, and I have no way, I can't take calipers out and start measuring my plasma to find out the diameter. Yeah, I could take the hole, but these are consumable parts that as they get worn out and wear in, they may open up, they make it a little bit bigger. It's one of those changes that they're sacrificial. You're going to use them, you're going to change them, and you're going to keep on, updating them. So the thing we're testing now is really, again, how big are we defining it? So I'm going to leave it here at 1/8 of an inch. Down here, depending on your machine, you have your cutter on or off, your gas on or off, your shutter open or closed. In this case, you could choose air, oxygen, or oxyacetylene, depending on what your command is for calling out different gas types. And then right here's the feeds and speeds. So again, the Baileys have 3 different controllers on them. It's got a Rich Auto, a Starfire, and a Fangling is what it's called. And those ones you'll never have to enter feeds and speeds here into BobCAD. You're just going to enter those. You're just basically going to give it the cutting conditions at the machine, and your machine's really going to apply it to the toolpath, to the code. But some of you may have to enter in your feeds and speeds here in BobCAD. So that's where we're going to do it right there. You have your feed rate. So whatever feed you want to run. I'm not going to fill it out. I use mostly Bailey, so I usually use cutting conditions. But you'll just enter in your feed rate. What are you comfortable with it cutting in inches, or depending on what your units are set to, inches or millimeters per minute? How long do you need to pierce? And that's in seconds. How long do you need to pierce to get through 1/8 inch material? Well, you can tell it how long it needs to pierce. And I'm pretty certain, but don't quote me on it, but I'm pretty certain that Thermal Dynamics A60, I'm sure one of you guys has it, that Thermal Dynamics A60, or it should be pretty much any plasma manual. Most of them have it in it. But it'll actually tell you what your pierce dwell should be based on the thickness of the material. So that manual actually answers quite a bit of these questions in case you don't know the answers, or a lot of the manuals do. I'll say the Bailey one for sure is a great manual. They got everything kind of marked down in there. Pulse frequency, power setting, and torch height control. Again, those really all depend on your specific machine. Some machines don't have torch height control. Some machines do. So the torch height control allows the machine to kind of make adjustments to get the best contact while you're cutting. A proper torch height control, though, can also go in and cut things like corrugated metal. So using that torch height control, it can actually raise the Z up and down to actually kind of zigzag or wave, do a wave up and down. Perfectly. It doesn't, you're not backing off and cutting the plasma from an inch away anytime the material dips down. You could actually have it do these wavy patterns, or from your rough material. Your arc slowdown slows down the arc moves that are output in the program. So if you don't enter a feed rate, there's really not much we can change here. But we really don't use the arc slowdown. You could, but I'm going to show you some other methods. Next, we then have our patterns. So we only have one pattern. It's standard. That's what we want. And right now you'll see that the system compensation is set to left. Because of the direction I had my geometry, remember my arrow's pointing this way going down, if I compensate to the left of that, I'll be inside. If I compensate to the right of that, I'll be on the outside. So I don't have any rotational forces to deal with. I don't have any climb versus conventional milling that I really have to deal with. So I'm just going to go in and say my system compensation is going to be set to right. And then that way it goes to the right side of the chain instead of the left. Next, we then have our parameters. Now, this is the main reason why we choose the profile finish toolpath over using the profile rough. The benefit of this is I don't have to add or delete or change any settings on this page. It's just going to be set. I don't have any allowances to worry about. I don't have to worry about multiple steps. So let's go next. Right here for the leads, just going to go vertically. Or in this case, no, we'll go with a parallel lead. So parallel lead, rule of thumb you want to follow, that I follow, is usually the When you're setting up the length of your leads, you use the radius of the tool. We're using what we're calling an 1/8 inch diameter kind of cutter. And so I can go in here, and the minimum I'd go is say 0.0625. I'm just going to say it's an 1/8 of an inch right there, and then hit next. Right here for my corner types, not going to make any changes to that. If you want round corners on your part, draw your part with round corners. What these are really doing isn't adding a radius to a corner or anything like that. What they're really doing is, I don't know, nothing. They're just changing how the tool interpolates the corner. So if your part's drawn with a sharp corner and you change these settings, you will still get a sharp corner. If it was radiusing or breaking your corners at all, then on this round option here, it would ask you what radius you want. So since it's not asking us for a radius, it's just going to change how the tool kind of rolls around the corner. Instead of a hard 90-degree turn like we see with sharp, round is going to round out that path, but you will end up with the same looking part. Next, we have our machine sequencing. This really only comes into play for me when I'm doing a bunch of parts at the same time, and I have a certain order that I want to cut them in. Most of the time, what I use is just the optimized option. I just let it pick the order that it sees kind of fits the best. So that's what I'm going to do. I'll just say optimize. And then hit next. So right here we have our advanced feeds, which we don't really have to worry about. But I do want to talk about this thing in the bottom corner, the corner slowdown. So if you think about your plasma, or probably your laser and Waterjet as well, when you make a cut, so let me open up a new window here. So when I go to make a cut, and we're looking at this, we'll say from a side view. So I'll say I'll just make it 1/2 inch thick. Son of a gun. 4 inches, 1/2 inch. There we go. So if you picture your cutter here, kind of cutting down this side, so it's standing vertically, cutting across the part. All right, just cutting through here. When you run that at whatever good speed you get, your plasma does not stay perfectly straight. All right, it's going to have a curve to it. So let's picture this as the plasma. So 0.125 length. All right, so there is my plasma. And so I'm going in and making my cut. Give me a second. I got this thing on. So I'm going in and making my cut. The problem is the plasma doesn't actually go straight through. It actually seems to move more on an angle. I don't want to say 45. We'll say 30 degrees though, where the tip of it, it's spraying vertically, but then it's kind of cutting. It's cutting through the top, then it's cutting through the bottom, which creates kind of an angled section like we see right here, like an angled cut down, but it could also be more kind of swoopy on the corner. So it might have a curve to it because it's kind of cutting through the top and then, blowing itself backwards, which is fine a lot of the times. A lot of times cutting simpler stuff, you don't have to worry about it. But if you're trying to be more accurate when you go around a corner, because what ends up happening is if we just let the machine run around the corner without ever slowing down here, we end up kind of cutting the corner off because our plasma's, again, not vertical. It's got that sweeping back. It's always sweeping back in the opposite direction you're cutting in. So if I get to this corner here, and the bottom of my plasma is somewhere more, down here where I'm working on an angle, and then the head of the machine starts turning, well, I'm going to nip off some of that corner potentially, some of that extra stock that's around the part. And so they added in this corner slowdown option right here, and you turn it on. You can say whether you want to do all corners, just internal corners, or just external corners. You set the minimum angle that can be read. So, in our case, we set it to 5 degrees up to the maximum 175. So it's looking for corners that fall between those two angle ranges. Now, the distance from corner is how far from the corner we're going to start affecting this. We're going to start changing the feed rates or do whatever. And the distance from corner right now is just 1/4 of an inch. But again, all these boxes, you could change them, so it doesn't really matter. And then you have your arc look ahead count. This allows you to kind of look ahead 1, 2, or 3. I'm not applying that to the links. Yes, I am. All right, so notice we can't hit next anymore. So we'll go ahead and hit compute. And there's our part. My leads are not in the right spot. Oh, hold on. So I have my corner type set to round. So you'll see that right there. I have a lead in that's going around cutting, but instead of leading out, it had to radius that corner. So if I go back to sharp and I hit compute, now it's sharp. There's our parallel lead in. Then it goes around the part with the parallel lead out. So there it is. So this is a file I strongly, strongly, strongly recommend building or creating this kind of very similar part file to this. A 4x4 square. And again, now we're going to go in and we're going to cut. We're going to go take this out to the machine. So right now what's happening, that green line that we see around here, that's the offset for the side of the cutter to encounter the material. So if I set my diameter here to 0.125, and I got to be real close with this, but I'm just going to go ahead and put this right here on the edge. And so you'll see where it touches. That's there to represent the plasma. All right, right there. Now, what I want to do is I'm just going to go utilities and translate. I'm just going to translate a couple copies of this down. I want to just go straight down. So I'll go minus 0.5. That's a bit too much. Minus 0.25. There we go. So we'll go minus 0.25. And I want to do that for a couple copies. So we'll do, we just need 2. Right? Yeah. So we have 3 total. All right. So this one is set to 100 thousandths. So now what I'm going to go and do is I'm going to change this one. So I'll say entity modify. Let's see what would happen if we cut this. And it's not actually 100 thousandths. It's smaller than that. It's 90 thousandths. So we'll say 90 thou is the diameter of that hole. So hit OK. And then on this last one, we're saying it's an 1/8 inch. Well, maybe it's 150 thousandths. So I'll say entity summary, or sorry, entity modify. I'm going to set it at 0.150 and hit OK. So here's the thing. If I was to go cut this, and it is 1/8 of an inch, that's perfect. Right down the center line, just kissing the wall. That's perfect. We go down, though. This one's here. I got to slap. I forgot the dimensions I used. So let me just slap some dimensions on here. There's my, let's go 4 places. So there's my 1/8 inch. Why is my height so big? I guess I'm not that big. So there's my 1/8 inch. There's my 90 thou. And then finally, whoops. And then finally, 150 thou. All right, so if you were to think about this, that much overcutting is going to make your part not read as 4. It's going to read as something smaller because our tool was defined as 2, because our tool or our nozzle is larger than what we thought it was. We put it, we left it at 1/8. So it all depends. Now, here's the thing. If we were to go in and find out that, hey, this 150 thousandths seems more accurate, it seems closer to the machining, the size I'm doing, you can change it. You can always go into your feature and change it from 1/8 inch to 150 thou, or 90 thou, or whatever you end up needing to change it. So yeah, this is that little test. So you can see, again, if you cut it with the 90 thou, with a 90 thou tool, we're not really touching the part. We'd have to move this all over. And that's what I didn't really want to do. I didn't want to have to shift anything or make any changes to the tool path. So, all right, man, we're getting a good class in here. We got 12 of you. Nice work, everybody. Glad you're here. So that's pretty promising. It doesn't look, it's not awful. The tool path looks good. What we really need to verify at this point, for anyone who's doing, that plans on doing this, is make sure your post is right. Make sure you pick the right post first, and then go and post your code. All right. When you post your code, you'll be able to look through here and kind of see the sizes and everything, find out if everything looks right. Save it if you need to, or save it if you want to, or do this later. But let's just go ahead and simulate it. It's not a huge deal for, you know, this isn't a crazy part to simulate or anything. You don't really need it, but I'm going to let it load up. So plasmas, I believe it's plasmas and lasers both show up with a red tip, and then the water jets have a blue kind of tool sticking out of them. So that's what I got right now. So I'm just going to go ahead and keep it kind of slow. Don't need to go too fast, and say run. And you'll see it's just going to go in and cut a 4x4 square. Now, if you're going for it, now you'd pull it out of the machine, give it a measure, find out if you're off at all. And yeah, you can use a picture just like this. Just like this. You know, if I find out that my plasma sprays at 150 thousandths, then I'm going to go in and I'm going to change everything to 150 thousandths. So hopefully I don't forget it again. But that might not be, you know, you just got to find out what your diameter is. And this little project will help you figure that out. So give me 1 second. I got to take a drink break. If you guys have any questions, this is a great time to ask them. We're going to move on to a little bit more complex CAD. It's not too bad. You'll see here in a minute. All right. Now, I'm sure a lot of you were signed up for this a little while back. I'm not sure how many of you signed up in the last little while, but if any of you signed up today because you saw Al posted something on Facebook, well, I'm glad you're here. And I saw that as well just before I started this whole thing. I thought it'd be a fun little thing because I usually keep the CAD very simple when I'm working with y'all doing laser plasma water jet, because most of the geometry is simple. You might get into some goofy shapes once in a while, but we don't usually ever need a 3-axis or a 3D part, not 3-axis, a 3D solid model. But for some things, you do need a solid model. And I don't know about you guys, but something that I've been hearing from people over the last couple of years that's getting bigger and bigger is making custom grills. Custom, not for cars, like not grills, like fire pit kind of things. You know, rolled up fire pit. You blast it out flat and you roll it up. Another thing I've been doing a little bit of is it's more of my laser guys that are doing it, but using a laser or a plasma to cut a hole that can fit another, say, pipe in it that you're going to roll. So here's the kind of example that Al made. I'm just going to draw it out. So like I said, this is going to be a little bit more probably in-depth than you guys normally go with with the drawings you have to make, but it's not too bad. So I'm going to start off and make a new layer, and I'm going to call it solid, just so I can put the solid there later. Now, this might be the first time some of you are seeing this UCS tab down here and how it works. Now, the UCS, I believe it stands for User Coordinate Systems. Yeah, because it's not universal or anything like that. I think it's User Coordinate System. So by default, we're always opening up our BobCAD in a top plane, a top UCS, and that's where we draw everything. We also, by default, have a front UCS and a side UCS. So let me just draw, I just want to draw out a cube real quick just so you can visualize. Here's a 3D cube. I'll make it 10 by 10 by 10. Way bigger than it needs to be. But this would be looking at it. This is an awful one to do, but let me do it this way. Here, I'll do this. An arc, we'll make it 10 in diameter, 20 in diameter. So here's a top plane arc. All right, I'm just going to slap it down right there. Now, if I switch to a front plane UCS, that's the difference. So it's the orientation in which we draw our geometry. If I go to a front, there it is. We're looking at kind of the front side of the cube instead of the top. And if I hit the letter S on here, the letter T, I can't do it here. Let me just set this right on top of that. So you'll see our coordinate system in the center actually changes. Our top UCS has the blue arrow sticking up. Our front UCS has it sticking forward, and our side UCS has it sitting sideways. And it's looking at it kind of like this view here. So again, this is a good way to kind of represent your different shapes. So I just want to go in and I want to use this side UCS, all right? And I'm going to go in and start by making an arc that is, we'll say the diameter is 3 inches. And I'll hit OK. Let me zoom in on that right there. So there's our 3-inch arc. And then I'm going to go ahead and make one that is 2.75. So we'll have 1/8 inch walls on here. So I'll hit OK and cancel out. And there we have our kind of wireframe for this. So when I go to do this, the reason I like to draw it this way is now when I go to a top plane, that's already rotated for me. I could have drawn it straight and then done it, but I didn't care too, and then rotated it. But that's a lot easier. You just draw it from a side plane. Now what I'm going to do is I'm going to take this. This is going to be a tube eventually. I'm going to create it as a tube, and then we're going to unwrap it to make it a flat object that we could cut and then kind of roll back up. A very small scale example. So I'm just going to go to Create 3D and then Extrude Curve. I'm going to pick that geometry right there. And I'm going to go ahead and make it, we'll just say 8 inches long. So I'll hit OK and cancel out. So this is like having, a 3-inch pipe. I don't think I have the offset right for the size here, but we can find out. So I'm going to go up to the Create 2D tab here, and I'm just going to create another arc. I'm going to set the diameter to 2, and I'm going to move it to the center of that pipe. So I'll just go 4 inches down. Now you don't see the preview, but I promise it's there. So I'm just going to hit OK and cancel out. And if I rotate that, there it is. Now what I'm going to do is go to Create 3D and Extrude Cut. And I can take this arc right here and I can extrude it through the model, just like that. Now, if you were cutting this, I do have some customers that have, 5-axis lasers and water jets and stuff like that. And they'd be able to go in and cut this right on the pipe. But some of this other stuff is, if you're doing like the, like a, what you call it, the, I keep forgetting it, fireplaces, the fire pits and everything, you're going to cut it flat and then you're going to roll it up. And so I can't go in and just cut a perfect circle in here if this is actually getting cut flat. So I didn't plan ahead. Give me 1 second. I just want to move this solid onto the correct solid layer there. There we go. So now I can hide that CAD. There we go. So now that I have the solid model, what I need to do is get this as wireframe geometry. I need it as the geometry I would want to flatten out and cut. And so I'm going to go over here and right click and add a new layer. And this feature is called Unwrap. So that's what I'm going to name it. Now you can find the Unwrap feature by going to Create 2D and then right up here next to, contour, all that stuff, next to the Extract Edges area in the utilities. So you just go to Unwrap. Now the diameter, you can either go in and define the diameter. We have a 3-inch diameter, or there's an option to just do it automatically. And that's what I usually end up using, unless I have a different, multiple sizes. Maybe you got a stepped part that's, a 2-inch diameter, then it goes up to a 3-inch diameter, something like that. That you might want to go in and define based on which surface you're picking. But for me, all I'm going to do is pick that surface, just like that, and it flattens everything out. And I can hit OK and cancel out. Now, if I turn off my solid, I'm left with this geometry. And you'll see that is not a perfect circle, but it becomes a perfect circle or a circle when you wrap it back up. So for my part, what I'm now going to do, you'll notice it didn't give me end lines. All we did is unwrap it, kind of the edges. So I just have to go to line here, and I'm just going to join that point there to that point there, and I'll go to this side, and then that point there over to that point there. All right, and cancel out. Now, what you'll also notice is it's at a height. It's raised up, and I don't actually need it raised up at all. What I'm actually going to do is take this whole thing and translate it so that this corner here is, we'll say, a 1/2 inch away from my XYZ origin. So to do that, we go up to utilities here. And then right here, we have translate. On translate, the first thing I'm going to do is pick my entire piece of geometry. By default, it's going to grab the center of the geometry. But I don't want to control the center. Yeah, I could go figure out the length of all this stuff, but I don't want to. I'm going to say pick. What pick allows me to do is I can now hover over this bottom edge and pick this bottom point here. This point, I want that point to end up at x 0.5, y 0.5, z 0. So it's going to drop it down in z and move it for the x and y moves. And then I'll just hit OK and cancel out. And so that represents my part. Now what I'm going to draw is a rectangle. So I'm going to go create 2D rectangle, and I'm going to go ahead and make it, I'll just say, for those of you that got a 2x2, it's whatever size your machine is or whatever size piece of stock you got. If you got a 4x8, you could set up a 4x8. If you got a 5x10, go 5x10. 2x2 is what I'm going to do right here. So 24 by 24. And I like to draw my stock. I like to draw these rectangles that represent my stock. Only because it makes my life a bit easier when I go to actually set up the stock for this. So this really is just stock, and kind of the best thing to do for this would be to make a layer, call it stock, and then right here, I just want to take it and put the bottom left-hand corner on XYZ 0. So just like that. Now I'll hit OK and cancel out. And there we have it. So now we have our stock drawn out. So the next step would be, do I only need one of these? Do I need more than one of these? What's the steps here? And so there's quite a few ways to actually make more than one part. There's toolpath patterns that allow you to pattern it to the geometry, and I'll show you guys an example of that. But there's also just using the model, using your CAD and moving extra copies over. So I'm just going to go Utilities and Translate, and I'm going to hold Shift and pick this inside circle shape there and the outside shape. And I just want to give it enough space to go straight up. So I don't want to move over an X at all. I don't want to move it all in Z. I want to leave it right on that Z plane. And so in Y, let's say 10 inches. So if I go with 10 inches, it leaves me a gap between the part. Again, I didn't measure what that is, the length of that edge right there. I could go measure it, or you can just pull out your calculator. We unwrapped a circle. So we could actually take the diameter 3 times 3.1459 pi, enter. The length of that chain, the length of these lines here should be about 9.4. So going 10 inches should leave me about a 60th gap between them. Let's go a little bit bigger. I'm wasting, I don't have much. I can't fit another part up here anyway, so I'll just go 10.5. So 10.5. There we go. That gives us plenty of space between the part to make our cuts. The big thing here, and the thing I always forget to do myself, is turn on the copy button. Make sure you turn on your copies so that you don't lose your original and just move it up to there. So I'll hit OK. Now we have these two. And since I'm in here, let's check our math here. If I measure this edge, we will see the total length is 9.4248. We calculated it out as 9.43. I'm close enough. Good enough. Did I do 3.14? I had a 141 is what I needed. I did it a little off, but that's fine. It gave you enough to know where I needed to be. This one I'm going to measure as well. This one is a total length of 8 inches. That's how wide I made it. Should have known that. So I'm going to go 8 inches. We'll do, let's say, a ½ inch in between them. So I'll go 8.5 inches. So again, I'll go Utilities, Translate. X will be 8.5. Y will be 0. And I'm just going to drag a box over these two parts. Now, one thing I do a lot is I over select like this, where I'm accidentally grabbing these edges for the stock. Happens to me all the time. But remember, when you pick a piece of geometry, to deselect it, all you have to do is click on it again or drag a box over it again. Remember, boxes for BobCAD, we don't have to grab the entire part. We just need that box to touch any portion of the geometry, and we're going to grab it for you. So you can draw these real tiny little boxes over pieces of geometry to select and deselect them. That's what I do a lot of times. So right there we have our 8 inch or 8.5. That's our gap down the middle. And I can't fit a third one, but if you wanted to see, you could come in here and say, give me 2 copies. And you'll see we're off by about, 1.5 inches, 2 inches right there. So it's not enough to get 3, but we can get 4 or 3 copies. We're going to get 6. We're going to get 4. So copies 1, hit OK, cancel out. All right, so now we have 4 parts getting cut, and I'm going to go machine them. So again, we're going to right click on our CAM defaults. We'll say new job. We're going to go milling. Again, I'm just going to use my plasma because I'm going to steal the stock or the tool path I've already done. And I'm going to go to my stock wizard here. So because I have this rectangle, this square around here that represents my stock, when I hit next here, it's automatically going to fill that size, 24 by 24. I just have to come in and give Z, we'll just say we'll do this. The thickness of those walls was an 1/8 inch, so 0.125 should be perfect, just like that. From here, I'll hit next. And my origin on this one, I'm going to use the bottom left-hand corner. Some of you guys might use that. Some of you might not. It's really dependent on your machine. This all comes down to whether or not you have a work offset or a G92. If it's a G92, you could go from the left. You just have to set your part up there. If I have a G92 for a plasma, I'm usually going to try and make sure my stock is a little bigger than, or a bit bigger than my part. That way I could kind of jog the machine in, get it over the material in the corner here, maybe a 1/4 inch up and a 1/4 inch over, and then all my tool path will start a 1/2 inch away, basically this distance away. But it all depends. It's really going to come down to your specific machine. If you're struggling with it, give us a call. Talk to tech support. Let them know what you're running into. We can help you try and figure out what you might need to use for an origin, or book some online training. Me and Andrew have done many hours of these laser plasma water jets, so we're pretty confident in it. And it's the best thing about the online training is we get to work with your parts. You guys get to send us some parts and say, this is what I want to make, and we're going to show you how to make them. Because some of you guys might end up doing a lot more CAD work than I'm doing here. We don't have a nesting package anymore. We used to have it in the older versions. But so we don't have any way to nest out parts. There is a program. I'll try and find the website. I can't remember what it's called. I believe it was at nest.io. Let me see real quick. Nope, that's not it. CAD nesting IO. So there's this one here that could potentially work. I've never used it. Give me a second. Let me open it up. But I believe if you guys ever talk to tech support, you talk to Jason, I believe he's used this. So you download it. It's a nesting software. And you can export DXFs right from it. I believe this is the one. It's an IO website. It's called deepnest.io. I'll play around with it later on today. I haven't had a chance to do it yet. But that's a killer one. Might be something that you can use. The way our old nesting worked, again, I don't know how this one does it, but the way our old nesting worked was basically you give it a group of parts that you wanted to nest. You'd have 5 parts that you want to nest. You'd pick all the parts, and then in the wizards, throughout the wizards, you would tell how many you want for each part. So I assume there's probably something like that. You just got to pay attention. Make sure you're not doing, make sure you're having space between your geometry. But also, this system might have the ability to do something called common line cutting. It might, if this is all nested through this, you can see like right here, it's very faint, and I apologize for that. That's can't zoom in on their picture here. A common line cut is where one pass makes 2 parts. It's cutting the left side of one part and the right side of another part as it passes through. We couldn't do that by default. But it's something you could definitely look into. You could set up your parts. Like technically, I could move this geometry over. Basically, I'd want to leave an 1/8 inch gap between these 2 parts, but then I'd want to draw a line down that gap. And instead of offsetting my my tool, instead of offsetting my cutter, I would just do a center line cut. And so when I go to, if these two parts were close together, say an 1/8 inch apart, if I made one pass down the middle of them, I end up cutting both of them. Now, I've gotten mixed results with my own stuff when you're cutting kind of two parts, more for milling, but I have had where the left side part looks great, but the right side didn't look as good. You know, you can end up with situations like that. But it's plasma. Really, you know, direction of cut isn't too important because there's no rotational forces we have to fight against. So, you know, there's that. So I just want to come in. That's it. I'm going to hit OK. So I have my 4 parts done. Now, after you guys have your tool path done, after you've made a tool path, you know, after you've tested that 4x4 square that we created, that we did just a few minutes ago, and you've tested it, and you found out that your diameter that you have your stuff set to is properly set, then what you could do is actually save that tool path. So I'm going to go right here. I'm going to say that this did properly set. My plasma is 1/8 of an inch. Perfect. Again, this is those dialing it in you guys need to do. But after I have it, I can right click on here and either copy and paste, meaning I have the part file open like I do here, BobCAD 1, I can copy it. I could bring it over to BobCAD 3 and I can paste it. The problem is, what if I'm just working on this file? I don't have any other files opened up. Well, the best way to save it is to save it. Instead of copying and pasting, where is it? Save the feature. So I might have more than one in here. Yeah, I got a bunch of them from plasmas and all that stuff. So the biggest thing here is you want to make sure that you label it so you know what feature it's for. Now, for those of you that you don't enter feeds and speeds in BobCAD, the thickness really doesn't matter. I mean, it does matter when you get out to the machine, and it does matter when you set up your leads. You know, if you're cutting 1/2 inch thick material, you have to pierce longer than when you're cutting 1/8 inch thick material. So that stuff will have to be factored in, but most of that stuff, for some of you, will be done at the machine. The leads will not be done at the machine. The leads will have to be done in BobCAD. Again, go through the manual, look in your manual, see if they have cutting conditions in there, because I know for a fact that Thermodynamics A60 will tell you how long to pierce and how far away to be from your geometry when you look up the material. Like if you're doing certain thickness of aluminum or steel, it'll tell you how far away to try and start, how long to pierce, and then what feeds to use. So it's kind of all ready to go. So this is just going to be, I'm going to call this live event, just so I know which one it is. Live event plasma toolpath. All right, save. Now, the cool thing about that is when you save a toolpath or when you copy and paste a toolpath, we remember every setting you put in. So for those of you that don't get the luxury of putting all your feed rates in at the machine, you're going to put them here in BobCAD. After you set those feed rates and pierce dwells and all that stuff, it's saved for good. The only difference would be if you have different gauges of material. If you go from an 1/8 inch up to inch thick material, those feed rates are going to be different. So you would want to save a separate toolpath for each thickness. But even that's not that big of a deal, because I could load a toolpath that was made to cut an 1/8 inch. I could load that toolpath up, pick my geometry, go into the settings, and I could change those settings to make it ready to run for something that's an inch. And then when I set, after I compute it and everything looks good, I'd then save that toolpath. So now I'd have a toolpath for the 1/8 inch, and I'd have a toolpath for the 1 inch thick or whatever else. So now that the toolpath is saved, I can right click on Machine Setup 1, and I'm just going to go down to Load Feature. And I'm just going to go ahead and pick my live event plasma profile here. And it'll say, do you wish to use the same type of feature and depth values? Yes, I would. Now, again, when you copy and paste, when you save and load, we remember everything you did except for what geometry was selected. So I'm going to start by, I'm going to go over to my layers here, and I'm going to hide my stock layer just so I don't accidentally select it. And I'm also going to just hide my stock because I don't need to see it right now. So I have all these parts. Now, BobCAD's pretty good about cutting the inside of the part and then cutting the outside of the part. But I have had times when that's not the case. Sometimes you it doesn't work that way. So if that's the case, you can see it in the simulation. But if that's the case, you may end up having to break your parts down into two tool paths or two sets of tool paths, one for inside shapes, one for outside shapes. And that's as difficult as it'll get. So I have this. I'm going to try and do it all in one. I'm going to right click on geometry. I'm going to say reselect. I'm going to drag a box over all my geometry. And then I'm going to look at everything. You could look at all your chains. The tool path that we saved, I believe, I'm pretty sure, we had the compensation set to the right. So I want to look at all these leads here and see to the right is the direction that I want to be on. So that'll put me on the inside there, and to the right will put me on the outside there. Now, another thing to take note of is if I do inside shapes versus outside shapes, look at the outside shapes. If I do a parallel lead-in on those, it's going to work great. But a parallel lead-in doesn't really work on the inside of a arced kind of piece of geometry. So I am going to have to go change my leads and probably go with something like circular or a right angle, probably a right angle lead makes the most sense. But I'm just going to start by hitting OK. And then I'm going to go compute the toolpath. So I'll just right click on the feature 2 axis and compute all toolpath. You'll see there's my little parallel leads there. Like I said, they're great on the sharp corners on the outside, but it doesn't really help us on the inside. So we could do one that kind of works for both of them. We'll edit our feature. I'm going to go to the leads tab. I'm going to do a right angle lead, and I'm going to hit compute. And now I have this little right angle. Don't know if it's the right length. You know, this is 1/8 inch thick. I haven't really defined what the material is. But there it is. Now we're doing all 4 of those. So if I save this, I'm just going to do a save as. Let's go. I'm going to put this in my... The heck is it? Oh, it's on my desktop right there. So desktop, repeat training. Do I have a laser plasma? Well, yep, right there. So this will be my unwrapped. Right there. All right, so now we can go simulate. I always like to save before I simulate. That's one of the biggest tips I could give you guys. I mean, save often anyway, but anytime you're about to run the simulation, save. All right, because the simulation can be, depending on your computer, depending on everything, can be one of the hardest hitting things your computer deals with while it's loading up, you know, while you're working in BobCAD. Plus, you save often. We've all gotten burned. No point in doing it more than once, right? Even after you do it once, it'll happen more. You know, it'll happen. All right, so we're going to go up and say start simulation, and just give it a second to load. Now, what we're really paying attention to right here is the order that everything is cutting in. All right, let me move this stuff over a skosh. I want the inside shapes first, then I want the outside shapes. So I'm just going to slow this down a bit, say run. Don't need to go too crazy fast. We'll speed it up. There's one. Then it does the outside of that one. Now, if you didn't want to do the outside of that one, you wanted to do all the insides, then you would have to break it into separate features. You would have to have it as separate, separate pieces of, well, separate tool paths. You have a tool path for all the inside shapes and a tool path for all the outside shapes. So there's that one there. Final profile. So there's all that and that. There we go. Now we have 4 parts cut. Real simple, real easy. So I want to show you guys another method of getting those same 4 parts cut. And I'm going to do this by removing the geometry from the toolpath and reselecting just the first part here. All right, so I'm just going to pick those 2 and hit OK. And I'm just going to go and compute that. So we're on the outside there and the outside there. So this chain right here is backwards. So if this ever happens to you, it's a lot of times it's a sign that there's bad geometry. That's always the first thing to kind of take a look at. But I've already seen this. It looked good. I know I got good geometry. If you're ever concerned that you have bad geometry, duplicate geometry, broken geometry, go to Utilities, go to Clean Up Optimize, and drag a box over all your geometry, then hit OK. No corrections were made. That's great news. These things right here, these arcs, and we got 4 of them, but if I go into my entity summary, those things are each probably about 300 each. They're 315 entities a piece. And that's because it created them as a bunch of line segments instead of arcs. It's part of the unwrap. You know, it unwrapped it. Shouldn't be a problem unless your machine doesn't look ahead far enough and it becomes kind of a stuttery mess on that. But it's something you'll have to test out on the machine. And then if you let us know, we could see if, you know, sometimes it could be you got to change the you got to change your feed rate, maybe slow it down. There's some settings we can do to try and help that. Or you might have to rebuild this arc or this geometry with more arcs. So that's all good. It is all selected there. And so now I'm just going to go ahead and I need to fix this one here. The problem is this is broken into 315 little segments. So my kind of cheater way of doing it is I'm going to reverse the direction for both of these, this one and this one, by just right-clicking on default chain start point. I'll say reverse direction. Then I'm going to go ahead and recompute. So what you'll see now is we're on the inside here, which is correct, but we're on the outside here, which is incorrect. That works out for me, though, because I can actually right-click on the default chain start point now. And instead of doing a reverse direction, which reverses both of the arrows, I'm going to say modify. And on modify, I'm just going to click the tip of this arrow right here, hit OK, and recompute. And now we're back on the outside. All right, so we got the inside and the outside. So say you only drew out one of these parts, but you wanted 4 of them to get cut. What I have to do first, and I'm lucky for us, I've already done the math on it, but if I take a measurement, I'm just going to go evaluate, measure 2. And I'm going to measure from this edge here to this edge here. So my distance in X is going to be 8.5. Then I'm going to do a measure 2 and go from the bottom line here to the bottom line here. My distance in Y is 10.5. Now that's important because when I go to my CAM tree, I can right click on my feature 2 axis here, and down in the middle, right there, we have an option called add toolpath pattern. So instead of programming all 4 parts, or even drawing all 4 parts, I can technically just draw one and then say add a toolpath pattern. Sorry, give me 1 second. There we go. So when I add a toolpath pattern, there's a lot of things you could do. You could do an array, you could do a translation, you can rotate them, or you can set them up based on points. I want to do an array because I have a specific amount I want to move, and so I'm just going to hit next. So from that toolpath that it created, I want to move over in X 8.5 inches with 1 copy. Then I want to move in Y 10.5 inches, again with just 1 copy. The way that these copies work is essentially we're going to take our original, make a copy for the X, and then take both of them and make a copy for Y, but it's still just 1. So I'll hit OK, and you'll see we've now translated or toolpath patterned all those toolpaths. So if I save, and then was to say start simulation again, it should run in the exact same order as before. So I'll just say run, starting on the inside and then doing the outside. Yep, just like that. There it is. So that's the toolpath pattern. And another little thing I just want to point out, and this is for those of you that have bigger machines, 4x8s, 5x10s. If you create your stock as this, big 4x8 sheet of material, the simulation is going to look awful. It's going to look really bad until it finishes. So always make sure, if you see it looking bad, let it finish the job, and then it does this automatic, it just disappeared, but it does this. Come on, it'll show up again for me. Whoops, dang it. I meant to show you guys that in a second. Hold on. Let me run this again. So as it finishes, I want you guys to pay attention right here on the bottom of this simulation. Let me speed it up a bit. Right here on the bottom of the simulation, you'll see this automatic quality improvement of the view area. And what it's doing is it's cleaning up that geometry. That's what you want to wait for if you have the three axis. I can't think. That's what you want to wait for if you're using a big piece of material, a 4x8 or a 5x10. So there you go. Now, other thing I want to show you is I want to see these parts. I want to see what they look like done so you can get a good idea of it here, but those extra pieces of geometry are kind of in my way. So what I'm going to do is I'm going to go to this column here on the left, these extra tabs that we have, and the one right down here is the measure tab. Now, normally when this is not in use, you want to turn it off. And the reason I tell people to turn it off is because when you rotate in BobCAD, when you rotate the view of your screen, you click your middle mouse wheel down like a button and you move your mouse, it's going to rotate that part around. That is not how you rotate in the simulation. In the simulation, you left click, hold, and you rotate. So the reason this is important is on this measure tab, we have this option called remove chips. So I'm going to say remove chips, select chips. And so when we use this, we actually use our middle mouse wheel like a button to tell the simulation what to get rid of. So what I do is I hover over an area I don't want, and I click my middle mouse wheel like a button. And you just wait a second, and it'll disappear. So I could do that to all of these pieces of geometry. Oh, I accidentally clicked that one too early, but whatever. Get that one, get that one. So you'll see there's my three parts, and I accidentally got rid of the wrong one over there. But they're all the same, so I can get a good visual of it. And there it is. Now, I don't have any way to rewrap that to find out if that's perfect, but we did unwrap it, and we did create the geometry based off that unwrap, so it should be pretty good to go. So there it is. There's our part. So we'll close out. All right, so if we go back to our cheat sheet, we'll use this now. We've gotten through the point of, let me go back a page, of step number 5. Come on. So we've gotten through step number 5. We did our tool path. The machining order. Now, the machining order doesn't really apply to us. If we go in here and we look at our machining order, we only have the one feature. The one feature, though, is smart enough to know that it should be doing the inside shapes and then doing the outside shapes. And as we saw in the simulation, it is. That's the only thing we really want to double check. And it's not really, it doesn't really have anything to do with the machining order. Now, it could have something to do with the machining order if you decided to do a 2-axis feature, a plasma, laser, waterjet feature for the inside shapes, and then a feature for the outside shapes. You'd have to make sure those are in the right order. But really, it's just do all your inside shapes first, then do all your outside shapes. And it should always come out in the correct order because you're only using one tool technically. So, all right. So the machining order, again, not going to be super relevant for what we need. But, if you have multiple plasma paths, you got to make sure they're in the right order. They're cutting. Whatever the order is you see inside the simulation, that's the order the job's going to run in, though. So it's not, if you're watching the simulation, you don't see any problems, you're probably fine. All right. So now I have, step number 7. So verify tool assignment. We don't have anything to verify. Verifying the tool assignment means going in and seeing what tools are used. We only have one tool. So verifying the tool assignment, really the biggest verification we're going to do is make sure that that diameter is the right diameter for our plasma. And again, we're going to do that by just machining a 4x4 square. And like I said earlier, if it's an 1/8 inch, it'll be right on target, 4 inches across. If it's smaller, or if the part comes out larger than 4 inches, then your tool is set, or your tool is actually smaller than what we set it up as. If it cuts the part too small, your tool's too large, or actually in that case, our tool would end up being, our tool's too small. It needs to be 150. And then that way it would actually take this, you know, even if it's 150, it's just going to offset further to the right here so that that edge is cutting just like that 1/8 inch right there along that edge. So just be aware of it. That's kind of the first test I would have you guys do if you haven't really gotten into this yet. And after talking to a lot of you plasma guys and gals, some of you guys just, it's like a table in the shop. It's something you're not using, and it's something that you just haven't gotten the training on it and know. Especially Bailey. If you guys have a Bailey plasma or even router or Waterjet and you haven't been running it, let us know. We could actually come out to your shop. We can do this for anyone, but Bailey we're pretty good with because we work with a lot of them. We can actually come out to your shop, teach you a bit about BobCAD, and go jump on that machine and try and get something moving and get some results. So we've done that many a times. If you're interested, call I think you're talking to David now. He's the one in charge of all the training. So call in and talk to David for training, and me or Andrew will come out to your shop and help you run some stuff. So if you're interested, let us know. Otherwise, there is a lot of help online. The guys at Bailey or Industrial are really, I've yet to have an issue with most of the guys that I've talked to for any company for plasma, because it's simple. You know, it's real simple. The code's simple. Everything's simple. Might as well ask them, and they can usually help. All right, so that was, let me go back to my cheat sheet here. So we verify the tool assignment. Again, we don't need to do that. We simulate the final program. We did that. Everything looked great. But if you do find problems, the main things that are going to be your problems in the system, in here, are going to be other than the obvious ones like feeds and speeds, that could always be an issue. But your leads will end up being probably the biggest killer. And a lot of it comes from the fact that, sometimes I can use a right angle lead. Sometimes I can use a parallel lead, but sometimes I can't use both of those on the same part. So like in the case we're in now, I could end up taking these tool paths that are cutting the arcs, and I could set those up as internal tool paths with a right angle lead in. I could then do like a simple copy and paste of the tool path, and I could do the outsides with parallel leads. But the benefit of doing that is you have two tool paths, and you're getting them to lead in the way that works the best. A parallel lead in works the best on a corner because you're actually piercing away from the part and then coming straight into it. Right now we're doing these 90 degrees. So we got to pierce, feed over, and then cut 90 to cut the part. So it's a little bit more abrupt on the plasma. It's not like we got to worry about a tool breaking, but if your feeds and speeds are set real fast, you might lose your cut. You might not be blowing through the material anymore. So, all right, so that's, you simulate the final program, then you post the code, then you generate a setup sheet. So we'll go ahead and post the code. I'm using this BC3X plasma or the BC plasma post. But again, you'd always make sure you have the right post processor and then hit post. Now, again, depending on your machine, you might have a G54, you might not. This one, this generic plasma that we have here, does have a G54. So I can actually go in, I can set up, I could, zero out my machine right at that bottom corner, and then I'm set for G54. I can move the head wherever I want, and it still knows where G54 is until I shut the machine down, and it forgets all that. The other way of running it, let me switch to one of these Bailey posts. I believe it's the Baileys that do it. Let's find out. So we got the Bailey Fangling. It's one of them. So this one, when I go to post the code, you'll see there's no G54 in the code here. This is the one using that G92. And so what G92 is going to do is wherever the head of your machine is sitting, when you hit go, that's X0, Y0, and all your moves will then move from there. So you'd want to have your machine, you'd want to have the head of your plasma in the bottom left-hand corner, where we have our origin. Like I said, whenever I use a machine that has a G92, usually I'm just going to pick a piece of stock that's a little bit bigger. Something that's got a little bit of wiggle room. So I don't want to start right on the edge, right on the corner. What I'll do is line up with the corner and then jog it in a quarter inch over, quarter inch up. And I just want to make sure that all my parts would fit within that kind of section. So again, it's dependent on this guy right here, how your machine's going to run. But there's our code. Again, very simple code. This one looks to be, okay, I was about to say it looks to be missing a lot of things. You'll see there's our MO8, shut the plasma off, wrap it to the next location, MO7, turn it back on, make our cuts. These super long ones here, as you can see, that's just really long. It's all line segment moves. That's all happening, again, because of how broken those pieces of geometry are. So that'll, there's actually going to be a decently long set of code because we got, a couple thousand entities on the screen. Scroll down to the bottom, 1,300 lines of code to make those 4 little parts. But again, that's because this isn't a real arc. It's kind of a, I don't even know, like an oblong, a little wider and fatter on the ends than but looks good. There we go. Oops, didn't need to rotate. So there we go. We post the code. Now to save this code, you're just going to right click and say save as. I'm going to go to my repeat ones. Where do I got it? Right there. Laser plasma Waterjet. So this would be my unwrapped geometry. You give it your name and then save it as the file extension your machine accepts. .nc is probably pretty good. That one's usually fine for most of the machines I deal with, but your machine might have a specific file type or might just be a text file, so you change it to a .txt or whatever. If you are going in and manually changing this file extension every single time, you can actually do it inside of the CAM defaults. You right click on CAM defaults and you go down to current settings here. And then you pick the machine that you use all the time. So I'm going to go ahead and use this BC3X plasma. Now, when I pick that, if I go over to the posting tab right here, we have our NC file extension. So for me in this machine, it's always going to try and save it as a .nc. Again, if you need a .txt, whatever you need, go ahead and just type it in right there. Add that in, have your .txt, and you're good to go. It'll always, from then on out, save, default save to a .txt. And you can actually have, if you got a plasma and you got some milling machines and they take different file extensions, each machine can have its own separate file extension. They will work independently of each other. So I'll hit OK. And so you'd save your code. And then the final step is generating a setup sheet. Now, I don't know what generating a setup sheet, if this is going to help you guys much, but it is an option and it is something we can do. So I always just go to my milling tab here, right here, and there's generate setup sheet. But for me, there's a little setup that I do before I generate my setup sheet. And that is I'm going to unblank my stock. So I have kind of a visual. And then I'm going to go right here to my machine setup one, and I'm just going to left click on it. I'm not editing anything. I'm not really doing anything. I'm just clicking on it so that it highlights it here in the bottom left-hand corner for me. That way I can say, generate a setup sheet. I'm going to use the full setup sheet, and I'm going to hit OK. And again, the reason I do all that work is because it generates this setup sheet, and it takes a screenshot of the part for me. So now I know where my origin is. I know what size my stock is. I didn't change the material, but it's set to 6061. And right down here we have our tool information and then our tool path information. Now, because I didn't give it any feed rates, it comes up with this outrageous number. But that's, again, if you had given it the feed rates, then you could calculate it. Another thing, though, you got to think feed rates are usually broken down into inches per minute or millimeters per minute, depending on your machine. I have a total feed distance of 170 inches. Pull up my calculator here. So if I have 170 and I'm going at 20 inches per minute, I say 170 divided by 20. Should take about 8.5 minutes to cut at 20 inches a minute. If I'm going at 170 divided by, I'm going 100 inches a minute. 1.7, I don't know what that is. 1 minute, 40 seconds, something like that. For 40, something like that. So not too bad. But again, there's there's no way of getting that calculation unless you put your feed rates into BobCAD, which some of you may have to. Now, the last bit here is what do you do with this setup sheet after you're done? What I usually do is I right click here. I go down to print. And then I got to move over right here. I use the Microsoft print to PDF and just say print. And it actually doesn't print the sheet. It just pulls it up right here. So I could go in here, pick my live events. That's not the one I wanted. That's the one I wanted. And I could name this. This is, Unwrap Geometry. And it's the PDF, and then save it. And so that's now going to be in that folder as a PDF that I can go and find at any point in time and use again. Any questions so far? Anything you guys struggle with when you're doing this? Or really, where are your guys' hang-ups at? I'll give you a second to type some in. What do you guys struggle with? Is it the CAM side, or is it more kind of the CAD side? And maybe in the future I'll focus more on whichever one you guys say. All right. Well, yeah, what else do we got for laser, plasma, water jet? There's really no differences between them. I'm going to do just to set up a new job real quick. This one's going to be for a laser. And I'll do my stock wizard next. Stock, calculate, there it is. Give it an 1/8 inch. All right, so I am going to have 2 jobs happening in here. But I'm going to go ahead and blank out the old milling job, the plasma job. And then this will be the laser job. So I don't have a tool path for the laser that I made today. So let me just go, we'll do the mill 2 axis. So Gary, would you say trying to etch and cut apart on the same file? So, all right, so Gary, good one. Let's do that. So etching versus cutting, same post, same everything. Usually the way you're going to do that, the way you control that etch is the power setting. And lucky for us, we got this new laser here. So for etching, you're not going to get a good simulation. I'll start by saying that. I mean, you could make it kind of close by just changing the depth that you say in your cutting to. But most of the time with etching, it's going to be more on the power setting side, So what I would do, let's say we want to etch these arcs into this. We don't want to cut all the way through. We just want to etch them in. So we'll go down to our mill 2 axis, select our geometry. Now, instead of picking all the geometry, I'm just going to pick the geometry I want to etch. That, and that, all right? And then I'm going to go ahead and say the depth, for the etch, I could say it's going 100 thousandths or 10. We'll go 20 thousandths. This is going to give me that representation in the simulation that I'm etching, but I'm not cutting all the way through because I'm not giving it the full depth. So I'll go ahead and hit OK. Next my way through until I get to the page where I pick my tool path. And I'm going to choose just the profile finish, just like before. Right here we have our tabs, no changes. Posting, no changes. Laser tool, no changes. And so you'll see the diameter of this was a bit smaller than the plasma. Again, same test could be done. You might go on a smaller scale. Instead of doing a 4-inch piece, maybe do a 2-inch piece. But cut a square and measure it and find out if it cut the right size. That's the thing that always, that's a big thing I'm dealing with. I got a couple guys with these Baileys that they're just not cutting. They're just not cutting right. Hold on 1 second. Yeah, give me 1 second, guys. So we've set this up. So really with this one, and it really depends again on how your machine handles it. For those of you that use those Baileys, again, you don't set up any of that information in BobCAD. You'll set up all that information at the machine. So Gary, if you're setting up the etching in BobCAD, it's usually going to be the power setting, pulse frequency. It's going to be those that have the cut conditions. So you have to enter in another page added. So you have a custom posting page is okay. So everyone, just so we're all on the same page. So on Gary's, he's got a Mazak that runs sub programs for cutting conditions. So he has to call out that sub program at probably the beginning of the cut or something. I don't have one of those advanced posting pages, the custom posts, but essentially the same thing's going to apply. You should be able to go in, and on yours, you'll have that advanced posting page, wherever it is. I'm not sure where it would be on your page. But you would enter in and pick the geometry for just the etch. So you'd pick the geometry that you want to etch and nothing else. All right? And then you'd go in, set up your cans or your cutting conditions, put in your sub-program callouts, whatever it is for the machine, and then finish setting this up. So you might not need this either. You might use something else. So you'll enter that in. Compensation, this is going to be up to you. This one's set to compensate to the left, but a lot of times if I'm etching, it's going to be a compensation turned off. I'm doing it as a center line cut, and I want to center line cut it. So then I can go next, right? Here's our parameters, nothing change, leads. With this one, I wouldn't really want, I'd want to turn on the etch probably right on the part. I don't want to right angle. I don't want to lead into it. Corner types, no changes. Sequencing, no changes. Advanced feeds, no changes. And then we'd hit compute. And so it's just going to go in and cut those arcs. And again, because you have that advanced posting page or whatever it is, this one would be set up for that. I would then copy this, paste it right here. Now when you copy and paste, remember that your cutting conditions will carry over with that. So I'll say, yeah, I want to use the same top and depth. Now the geometry is going to be reselected as just the outside bits of geometry. So here, 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 and here. And then I'm going to set my depth to whatever, a ½ inch. I want to go all the way through with this one and then hit OK. Well, let me check my start points. I want my start points all in these corners here. I'm going to all meet up right there. So we'll come in there, go around, we'll lead out. Ooh, I could actually pick this in a really good order, but I'm not going to worry about it. So I'll hit OK. And then I would go in and edit this feature. So editing this feature would now give you a chance to go in and edit the cutting conditions, the sub-program call out or whatever, and then go next. Next your way through. Really, the only change I'm going to make is I probably need compensation again. So I'm going to go with, I believe it's a right side compensation. I wasn't paying attention to the arrows there. Right side compensation. And on my leads, for this one, because I'm just doing the outside pieces, I'm going to go with a parallel lead. And I'm going to set the length to, this is, again, all dependent on how thick a material you're going, whatever your pierce is. And I'm going to go 1/8 inch and hit compute. And there we go. So it should be, I believe, let's look at this thing. Yes, we are starting here. We're going to start right there. We're going to cut our way around all the way. We're going to end up right here. It's going to shut off the plasma, lead back in there, cut its way around, and then lead to the next one. Perfect linking on there. That's what I wanted to see. Good deal. So now if I go to simulate this one, what we'll see is the etch that we did should show up first. It's small. I can speed that up a bit. But it should go in, cut a little bit. Doesn't cut all the way through, just goes that, whatever I set, 20 thou or something deep. Speed that up. Right there. And then go right there. And because you're doing the advanced posting page, these should both have, kind of independent sub-program calls for your cutting conditions called out in the post. I won't have them because I don't have that page. But that should do it. Did that answer your question there, Gary? Did that help? That's how I'd probably go about doing it. Perfect. Perfect. Yeah, that's going to be the best way. Break it into multiple pieces. Anything that, and the way I would do it is layer it. Do your layers. Put all your etching geometry on its own layer. Put all your outside geometry on its own layer. Put your stock on its own layer. Keep everything separate. And these can be some of the easiest files you guys work on. If you don't do that and you keep everything kind of in the same window all the time, they could be some of the worst parts to work on because there's just lines everywhere. And there's also the fact that some of you guys are doing sign work, and I'm going to do that on the next laser plasma Waterjet. I'm finishing up one right now. I've been working on it in my free time for a couple hours. It's got thousands of entities in it that we use BobCAD to generate the wireframe from. And it's got tiny little gaps all over the place. And I'm trying to laser it, and the laser I'm using, it's about 10 thousandths for the laser. So that 10 thousandths size is real small. And I got these tiny gaps. They're even smaller than 10 thousandths, but it breaks up the geometry. It makes it so I can't cut everything. So I'll show you guys that next time, either do it during this plasma one that we're doing or during a, or during a, the 2D CAD day, just going in and kind of doing repairs on geometry because it's tedious and it's not fun, but you got to do it sometimes depending on your parts. So, all right. Any other questions that I could answer for anyone? I'm pretty much done for today, but I'm going to be here. If you guys have questions, I want to hear about it. I want to know what you guys got. And we'll try and answer some more questions for you. If you don't have any questions, have a good one. We'll see you next week. I think next week's on, I don't even know what we're doing next week. Look on the website. I don't know what next week is. I don't know if me or Andrew will be doing it. So we'll see next week when it happens. But if you guys have any questions, feel free to ask some. I'll be here for a few minutes. I'm going to end the recording here in a second. And again, if I don't talk to you, have a good one. And hope to see you next week or whenever we do something you're interested in again.